Hello guys, welcome back. This is the part 5 of our snake game development tutorial in Java. So what we have so far right now is the snake and a simple menu that we can press enter and then start the game. Okay, so let's start it again. Okay, and then some collision detection. Okay, and then starting the game. So the one crucial thing that are missing in our game is the food. So we need to generate the food so that the snake can eat it, and we can grow the snake. And when the snake is becomes longer, it will be much difficult to control. And then we need to print some score here to show how many food that the snake already eaten. Okay, so let's start. Okay, so uh, the f- the first test that we need to do is to uh, create a setting of the food location. So we, here in the food class we can add a method. So public void set food location. So this is crucial because we need to call the set food location multiple times in a game. So whenever the snake eats the food, it will generate another food and then uh, show it in this specified location. So that's why we need to have a set food location as function to call for our food to appear. So this is also um, set location xy. Okay, so that is the set food location. Next, in our game engine, we have set the food to 200 by 150, but we can produce it randomly, so we need to set it as 0. And then when we start the game, we need to produce the food randomly in our game. So randomly means we need to have a some basic computation of the location or the possible location of our food. So we need to create another method here and then name it produce food. So produce food will be called multiple times. So location x, so let's set it first in 0, and location y will be 0. Then food, that set food location is loc x and location y. Now how are we going to produce this randomly? So the lower portion, let's create another method. So private int um, generate random on grid. So we need to make sure that the value that will be produced by this one will be the same, will be exactly the same as in the head, the location of the head. So as you can imagine, we can say that this one is a whole pixel. So let's color this one as blue. Okay. So what if this is an specified pixel? Since if you look at our snake, the snake has the size of 10. So 10 pixel. So we can assume that uh, this uh, these 4 blocks might be the head. So let's say this is the head and it is made of 10 by 10 pixels. So one box is equivalent to 5 pixel, 5 pixel by 5 pixel, and this one also 5 pixel by 5 pixel. And then the food produced and put in the coordinates something like this. Okay, so let's change this color to, okay, so for example, this is the food and this is the head. So now if the head is running towards the food and then it appears here, okay, sorry, it appears here, so there's an overlap. How can we say that the snake or the head uh, eats the food? So it should be, um, it should cover the entire food, not something like an overlap like this one. So we need to produce the food exactly where the head is, where the head will be possibly appear. So let's, if the head is on this position, the food should be here, so that if the snake is coming towards the food, it will be something like this, and then this. Okay, so let's clear this one, and then overlaps the entire food, and then we can say that the head or the snake eats the food. So if it covers the food entirely, that's the time that we can say that the snake has eaten the food, and the snake will become longer. So let's go back here. So to make that feasible, we need to generate a random number using the math class, math.floor. Okay, and here we'll have a variable of high and low. So the floor will return the nearest flooring number. So it is rounding down the value. Since we can generate a random number using the random method in the math class, but the random has a return of double, so we need to convert it to integer. That's why we have a typecasting here. So math.random, so times the minimum should be 1 plus high minus low, and plus low multiplied by 20. So that would be the computation. So this will appear, the random number will appear exactly on the by 10. It is not totally random. It will appear based on the size of the snake. So if the value generated is, let's say, um, our game form is 600 by 600. So if the generated number is let's say 17, it will be converted to flooring number, which is 10. So it will align itself with the head of our snake. So it will align like this one, or like this one, or like this one. Okay, so it will not going to overlap like this case. So we cannot check it if the food is being eaten by the snake. So we need to have a way to generate exactly that is aligned with the head of the snake and the body also of the snake. So this is the generate random on grid. So we can call it here generate random on grid, and then pass the minimum and maximum, the high and the low. So the high should be game form, that width divided by 20 minus 5. Then the low is 1. Then the same, or height. Okay. So this will make it exactly aligned with the head of our snake. So now we can call this produce food in our initialization. So here, so let's check. hmm Where is our food? Okay, so we didn't draw the food yet, so we need to draw it here. So in the else part, we can say that food that draw G. Okay. Okay, so there it is. So next is how to make the checking that the snake overlaps with the food, and then the snake becomes longer, and we will going to produce again the food. So that's the next task here. Okay, so the next step is to have a checking if the head overlaps directly with the food. So we need to have a method for that. So let's head back to snake. So here we already have a checking for the is dead, and then we need to have another method here. We can call it is food eaten, and its parameter is the food. So remember, the food is of type point also. So internally there's an x and y value here. So we need to check the head. So we need to get first a head. So as we have done here, we get the head using the snake body array list, index 0. Okay. So if a head that get location that x is equals to f that I think there's no okay, so let's head back first here. We need to return the current location of the food, so we need to create a uh, method public point um, get food location, then uh, return return this that food location. Okay, so go back here, and then f that get food location that get location that x. So if they are equal, then another checking if head that get location that y is equals to f that get food location that get location that y. So is food eaten, or we can return it as true, return true, otherwise it is false, return false. Now we can check, we can use this is food eaten in the game engine. So let's go in the update here. So let's check. So if snake that is food eaten, the parameter is food. So if it is already eaten, we can produce again the food, produce food, and then um, grow the snake. So grow the snake. Okay, let's test first if um, let's test if the game will generate another food if we eat the initial food here. Okay, so that's it. So if, as you can see, um, if we collide with the food, it means that the snake eats the food and generate another set of food. Okay, so but the snake is not growing, so we need to add the code for that one. Okay, so let's head back to the snake, and then let's add another a method. So we can call it public void grow snake. So grow snake is basically just adding a point object in the array list of snake body. That right. So snake body dot add, then new point. Okay. The parameter here will be the last index, of the snake. So we can int size is equals to snake body dot size. So we can get the last position based on this size -1, or uh, we can deduct it already here. Okay. That get location that x comma, so the same snake body that get size that get location that y. Okay, so that's it. So we are just appending on the last uh, portion of our array list the next body of the snake. So if the snake eats the food, we can call it here snake that grows snake, then run the program. Okay, so if we eat we need to eat at least 10 so that we can, so it's the snake now is growing. Yeah, it is growing now. Okay, so the next part is that when the snake is long enough, there's a possibility that it can collide with its body. So we need to add that code because currently there's none. So as you can see, I can overlap my own body and do not die. So we need to have some logic for handling that. Okay. Okay, so our next checking is the collision for the body. So we can add it here in the is dead because it is the same. If the head collided with the body, it is considered as dead. So we need to loop for for the entire length of the body, because we need to check if the head collides with any part of the body. So we need to check one by one uh, if the location of the head is equals to the one of the body parts of the snake. So uh, if head that x is equals to snake body that get, okay, that x, and head that y is equals to snake body that get I that y, then return true. So there's no, okay, so just don't need to have a break here because the return will break the is dead. So let's check. Okay, so if I've eaten the food, okay, 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 so let's make it long enough to collide its own body. Okay, so let's try. Okay, so I died when I collided with my tail. Okay, so that's the correct one. So our next part, or our next task, is to have a score. So currently we don't have any score yet, so we need to show to the player how many foods that the snake already eaten. So let's create a variable here. Foods eaten is equals to 0. So if it is initialized, we can set it again in 0. Okay, then let's print it here. So g that, let's set color it to blue, sorry, blue. Then g that drawstring score plus foods eaten. So let's show it in 10x, and then game form that height minus, let's say, 20. Now we need to increment the foods eaten whenever the snake successfully eats the food. So let's delete this first, and then go here. So foods eaten plus plus. So let's try. So as you can see, there's a score, but it's a little bit lower. So we can make it higher. So let's make it 40. Okay, so as you can see, when we eat the food, the score so the score increments by 1. Okay, so that is the next task. So our last task is how are we going to save the score. So let's say I already it overlaps. Okay, what happened with that one? Let's check it again. Okay, so if our last task is to create a high score, saving the high score. So the moment that let's say I already have 4 as a score. If I game over, uh, if I die, then game over. And when I press a restart, I can see the high score here in the lower right portion of our game form. So we need to save it in a separate file and then increment it. So if my current score is much greater than the high score, we need to update the high score with the current high score that I have right now. So let's say I already have 5, so the high score will be saved as 5 or 6 or 7. So that is our next task. Okay. Okay, so our next task is to create a way to save the score and the high score in a file. So it means that when we start the program, it will create a file and save the initial score there. And whenever we close the program and start again, we need to have a way to save the score and load the appropriate high score if there's any. So we need to create 2 functions here to load or to generate the file and save the high score initially and get the high score. So the first method here is the read high score. Okay. So we need to specify a default location uh, in our program. So let's say, so I have a here in the documents. So we can say desktop. Okay, so see, uh, if you are using a Mac, the root directory is the / sign, then the folder users, then the user, and then the folder under that user, which is desktop. I'll say that's highscore.txt. So if you're using Windows, you can put the exact uh, parameter here, like this one. So let's say C. If you're using Windows, C C users. Let's say my user, my documents, and the text file. So highscore.txt. So since I'm using Mac, I'm using this format. Okay. So I'm gonna annotate this for Windows user. Okay, so we have the default location, and let's create a line which is null, and then the value, let's default it to 0. Okay, so let's create a try and catch, because the class that we are using is required to be defined inside the try and catch block. So create a file reader. So file reader is equals to new file reader. So it will look at the file. So let's change this one, file name. So if the file name does not exist, the file reader will create it for you with an empty contents. So we need to import it. So it is under the java.io file reader. Okay. Next is we need to have a buffered reader. Buffered reader is equals to new buffered reader, and the parameter should be the file reader. Again, we need to import this one. So import buffered reader from java.io. Okay, so this is equal sign. Next, we need to loop. So while line is equals to dot reader dot read line is not equals to null, it means that uh, while it can read a line, we can uh, put the whatever value that this text file has. So this is the reading of our file, and then whatever the value is will be appended in the val, which is a string. Next, we need to close the reader, so reader dot close. Okay, so if val is not equals to null and not val that equals to empty, okay, we need to convert it to integer, so return integer dot value of val. So the integer dot value of will convert the val into a integer type because our return value is integer here. So if there's an error, we can so ex that print stack trace to show the what are the methods that causes errors in this method. And then if we need to return, okay, so this is the return. Now if the val has a null value or it is an empty value, we can return 0. Okay, so that's it. So the next method that we need to create is the update high score. So this method will update the high score whenever the current score is more than the high score. So again, the same file name, I can copy it here. So this is the location. You will see that this file will be created when we run the program. So next, we need again the try and catch block. Okay, so we need the file writer is equals to new file writer. File writer is the class that we use to write a file or write contents in a text file. Okay, so again we need to import it under the java.io. Excuse. And then we need the buffered writer. Buffered writer buff writer is equals to new buffered writer. So the parameter is writer, this one, and then we need to import it again, the buffered writer, and then we can now write whatever the value. So since the foods eaten contains the score, that is the parameter that we need to add. Then we need to convert it to string. So that's why we appended an empty string. So if you pass it like that, this one will, I think, it will generate an error, maybe. So then we need to close the buffered writer. Okay. And then print stack trace for some errors. We have one. Okay, so where are we going to call this two methods? So we need to call them in Okay, so here in our paint component, so here in the is game over, so we need to get the score. So score is equals to read high score, and then if score is equals to 0, we need to update high score. This is the first time that the score is being loaded. Else if foods eaten is greater than the current score, we need to call again the update high score. Then we need to show also the high score here after this one. So we need to copy the drawstring. High score is get high score, and then it should be appear in the lower right corner of our form. So game form that width minus, let's say, 100. Okay, let's try. We have an error where it is. So we have the get high score. The method is undefined for the undefined. So we have here read high score. Sorry, not get high score. So read high score. Let's run. So let's test the program. Okay, so our high score is, oops, we have an error. What is this? We have a print stack trace error, so it's very long. No such file or directory. So we have, so if it is just started, maybe we can generate, or we can, because this one read high score, we need to call the read high score first. Wait, read high score. So if there's no file for that one, so read high score is empty. Then if the score is equal to 0, update high score. So if there's no file with the same name, I think. Okay, let's check. Okay, so we don't have any file here in the desktop. Users will monitor our desktop. Let's check again the error. Here in high score, we need to create the file first before we can generate it. Okay, so we have already the read high score. So I think there's a problem here. I think we need to add a, because the moment that the snake died, that's the time that the file will be created. So let's add another catch here. So file not found exception. So file not found, you need to import it in java.io, and we need to no we don't need to print stack trace. We can output a much user friendly error message. There is a problem loading the file, or this one will be file not found. Okay, there's a problem reading the file or updating the file. Okay, let's try. I already have a high score, which is 2. So let's make it much higher. Let's say 4, 5, okay, 6. Then let's kill the snake. Is this the one? Okay. Okay. So let's run it again. Okay, this is the correct one. So I have a score 1, file not found. As you can see in the back, it is file not found. When the snake died. Okay. There's a problem loading the file. So what is let's check if the file is created. Okay, so we have the one, highscore.txt, and it doesn't have any value. Maybe we can if this is game over, so we can update the maybe we in our error here. So produce the foods eaten is the correct score. Okay, let's go back here. I think we have a problem in here, so we need to convert it to string. Okay, let's try it again. Let's try it again. Okay, so let's make it at least 2. Okay. Okay, so we have now the high score here appears as correct score. So let's make this snake a lot longer. So 2. So notice the score. So okay, so I have now 3, 4, 5. So if the snake dies, the high score should be 5. Okay, so that's correct. So we have successfully updated the high score and save it in a file. So as you can see here. Okay, so this is the score. So 5. So our snake game correctly loads the high score. So let's try it again. Let's create a much higher score. So 3, 4, 5. Okay. 6, 7, 8, 9, 10. Okay. Okay, so we have now the high score as 10. So that's it. That is the snake game that is a little bit complete. So that's it. This is our completed snake game in Java. So now guys, I want some feedback from you. You can suggest additional improvements on our simple snake game. Just write it in the comment section below and I will code it and record a video on that additional features that you want. Okay, so thank you guys for watching and don't forget to subscribe to this channel for more programming tutorials. See you guys.